Okay, let's discuss some example on conservation of momentum. And just to recapitulate, we said that F equals mdv over dt in some of the previous lectures. In fact, we said F equals m dp over dt, that is the rate of change of momenta, is equal to the force applied, where P is the net momentum of the system and F is the net force on the system. And we also said that if F is 0, then P is conserved. By conserved we mean that it remains constant. So let's take an example. Let's say we have defined our x and y axis, because we know momentum is a vector. Whenever we deal with problems in vectors, we need an axis system. Let's say there are two particles like this, and let's say three particles like that, and there's this third particle. This is 1, this is 2, and this is 3. If the momentum of the first particle is minus 2, 3, we know the units for momentum will be what? P is given as mv, where m is measured in kilograms and v is measured in meters per second, so the units of momentum is going to be kilograms meters per second. We are talking about vector p1 in Cartesian system, where minus 2 is the projection on the x-axis and 3 is the projection on the y-axis. I made a small mistake, this is plus and this is negative. And let's say p2 is given as minus 4, minus 5, and p3 is given as 0, 7. And these guys collide, and after collision p1, so let's say they collide, things, I don't know how they look after colliding, well, let's say somewhere, I don't know where they are, but let's say they have three particles, we don't know where, but we know that for sure the momentum of p1 is given as, let's say, and this is initial and this is final. So momentum of the first particle and then the momentum of the final particle is given as 4, 3. Let's say p2 is given as 3, 2. Now the question is, what is p3 final? That is the momentum. What is the final momentum of the third particle, right? So how should we solve this? We know the net momentum of all the particles is p1 plus p2 plus p3, that is we add them vectorially, and if we do that, we know that when we add vectors, all the x components add up and all the y components add up. So the net p is equal to be minus 2 minus 1. How about here? Let's say p3 is actually p3x, p3y is the Cartesian representation of the p3 vector. Then we expect, now this is initial and this is final. The final is going to be 7 plus p3x, 5 plus p3y, and this is final and this is initial. So how should we solve for p3x and p3y? Well, we know the initial momentum should be same as the final momentum, because there is no external force acting, so the net momentum should remain unchanged. and that gives us the equation that 7 plus p3x equals minus 2 and 5 plus p3y equals minus 1, and that gives us p3x equals minus 5 and p3y equals minus 6, right? So that was just an example to show that momentum remains conserved, and you can use this idea to calculate many things. We'll talk about more examples in the next lecture.